Greetings and welcome back. Today we're going to be discussing the topic of tire pressure monitoring systems, or TPMS. As we discussed previously in the video on tires, underinflation can lead to overheating of the tire sidewall and ultimately fatigue and failure or excessive wear of the tire itself. So proper inflation during operation is critical on tires as a safety precaution. Some vehicles are equipped with run-flat wheels or run-flat tires, where a driver may not actually know that their tire is low. Manufacturers had to come up with a system that would address the safety concern of a driver not being aware that their tire is low on air or has gone flat and is now running on the run-flat sidewall or the run-flat strip in the wheel. Manufacturers were given the requirement by the Federal Motor Vehicle Safety Standards, and this is according to number 138. It states that the driver must be warned by a telltale or a warning lamp on the instrument panel cluster within 10 minutes of a tire's pressure decreasing by 25% for all vehicles made in the 2008 model year and newer. It doesn't specify what type of system it needs, just that the driver needs to be warned if a tire goes below 25% of its manufacturer's specification cold tire inflation pressure. So TPMS systems, manufacturers had some freedom with designing the TPMS systems and how it's going to accurately measure that. Manufacturers in the industry designed two different systems that accomplish this goal. The two different types of TPMS systems are indirect and direct. Direct tire pressure monitoring systems monitor the actual tire pressure inside the tire and wheel assembly. This information is then transmitted to the control module that receives the information and warns the driver if the pressure falls below 25% or if there's another issue with the system indicating a concern at the telltale or the warning lamp. Direct TPMS sensors come in two different types, the main difference being on how they mount to the wheel. The most common method is to integrate it into the valve stem. The valve stem is actually part of a battery-powered sensor, and the valve stem has, through the standard valve core type, Schrader valve, has a path for air to enter into the tire. So this hole here is where the air comes out when it's introduced through the valve stem. This is mounted to the actual sensor itself and can be serviced. And these should be serviced routinely when tire maintenance is performed. These have a battery inside. The battery is not accessible. Direct sensors have a lifespan of about 7 years, with tires that have about a serviceable lifespan of 9 years. In theory, the tire should last as long as the sensor, or the sensor should last as long as the tire, and when tires are replaced, sensors should be replaced, making maintenance on the system a lot easier. When tires are serviced or replaced, it's up to the technician to look at the information on the tire and determine how old they are and whether or not it's due for replacement, and if at that same time the sensors should be replaced or if the sensors can be reused. Depending on the age of each one, may not be easy to tell. Inquiring with the customer may be another avenue for getting some of that information. On a direct TPMS sensor, it can have a rigid valve stem like this, or it could have a rubber style valve stem. The ones that have this type of valve stem are easy to identify from outside of the vehicle. Since this is going to be sticking out of the wheel, you can tell by looking at it that it likely has a direct sensor on the other side. The other type of valve stem, the one that looks like a standard rubber valve stem, isn't as easy to tell, but it is rigid on the inside. So it's not always easy to tell depending on looking at the wheel to determine if it has a direct tire pressure sensor in it. One more thing. The other style of direct TPMS sensor is a band mount. A band mounted sensor, like this, is not part of the valve stem. The band mounted sensor actually goes around the wheel, and the wheel can have a standard rubber valve stem for air to move in and out of the wheel tire assembly. And then the band mounted sensor would typically be 180 degrees away from the valve stem, but it would be tied against the inside of the wheel. So there's zero way of knowing, just by looking at the wheel and tire assembly from the outside, if it's equipped with a direct tire pressure sensor. Service information is always the best way to find out what the vehicle is equipped with. This band-mounted sensor is off of a Ford application, and this one is off of a GM application. There's some identifying characteristics on the labels, or cast into the molding of the body of the sensor themselves, but these are reading the environment pressure inside the wheel tire assembly, and then it is being transmitted via frequency to the module to give the driver any information needed from the system. With either of these types of sensors located inside the wheel and tire assembly, we have to be aware of how to mount and dismount tires so that sensors aren't broken by the technician doing the servicing on the wheel tire assembly. When the stem-mounted direct pressure sensors are serviced, they can be reused, but they have serviceable components on them. So these are disassembled at the valve stem area and reassembled into the wheel with new seals and a new mounting nut and tightened to specifications according to the manufacturer. Those kits are usually found available in packaging like this, and they are done by application or by types of sensors. More sensor manufacturers are making them universal to many different applications and then programmed to the vehicle. So depending on the type of sensor you have will depend on the type of rebuild kit that you use with that sensor. On the packaging here for the sensor service kit, it gives a model number, it gives a brand and a model number with a part number. It also gives torque specifications for the valve core and for the nut. In order to service these, using the proper service tooling, it's important to get everything tightened to the specifications needed. This kit includes an inch-pound torque wrench, and like all torque wrenches, this should be zeroed out anytime it's not being used. It has different valve core tools. It has a spanner wrench for holding onto some different valve assemblies. And it also has torque wrenches programmed to specific torques that are not adjustable. Here's a 12-inch pound and a 35-inch pound. It also comes with other types of valve core tools. This one, which is a flat piece on the inside, can be threaded onto a valve stem and deflate the tire without having to sit there and hold the valve stem depressed. And a plastic service tool for the nuts. And this kit will be used to service, disassemble, and reassemble a direct tire pressure monitor, a direct sensor that's mounted at the valve stem. In order for these sensors to be serviced, they must be fully disassembled and all seals and serviceable components removed first. So now we can use our kit, and following the specifications on the kit, we can replace all the serviceable components and mount it into a wheel. First, the valve stem will be mounted back to the sensor body. And then when tightening these to spec, this is the 12-inch pound torque wrench. You just rotate it until you feel it give a little bit. That way you know it's reached its torque specification. Now we can prepare this to mount into the wheel. We'll put our rubber seal on it, and this will seal the air behind the valve stem into the wheel and tire assembly. So now with this seal in place and its seat in place, we can mount it to the wheel. When installing this into the wheel, the sensor body should be as flush as possible to the wheel. Inserting it into the wheel like this, it is nice and close to the body. There's still a little bit of a gap behind it, rather than mounting it this way that sticks out from the wheel. If it's with it as flush as possible, there's less likely chance of it breaking when coming into contact with any part of the tire when the tire is being mounted or dismounted. Then the nut gets installed. The torque specification on the nut is 71 inch-pounds. We'll take our inch-pound torque wrench and set it to 71 inch-pounds. Set our torque wrench to 71 inch-pounds. Find the correct socket. And wait till this clicks over, and then you know you're tightened to your specification. And then back this back out to 0 every time. Last piece is the new valve core. The valve core has seals on it in 2 areas. The body seals along this red band here, and that seals inside the valve core assembly. And then the other seal is on the base of the valve core, where it opens and allows air to go into the wheel and tire assembly. There's a little seal in here, and that red part, could be either red or black, is also a seal. We may not be installing this quite yet. If the tire still needs to be mounted, that'll likely happen first. In our valve core torque wrench torques the valve core to about 2 to 5 inch-pounds. Pay close attention. These sensors aren't all the same, and they're not all serviced the same way when it comes to the scan tools and in programming the sensor. Some sensors can be mounted straight out of the box into the vehicle's wheel assembly, installed on the vehicle, and then the reset procedure and programming procedures can be performed with it in the vehicle. Other sensors have to be set to the vehicle before installation to the wheel, meaning this has to go into the scan tool and be programmed with information before it's mounted in the wheel and tire assembly. If one of those is installed into the wheel assembly before it's been programmed, then that sensor is not going to be reading anything after it's all installed on the vehicle. Rather than find out after it's been mounted to the wheel, tire mounted to the wheel, tire and wheel assembly balanced, tire and wheel assembly mounted to the vehicle, torque to spec, vehicle put on the ground. At that time is the worst time to find out that this was supposed to have been programmed prior to installation. So make sure you understand what type of sensor you're working with and how to service them. The other type of system is the indirect system. The indirect tire pressure monitoring system does not actually monitor the tire pressure inside of each tire. What it does is use the wheel speed sensors to detect when a wheel is underinflated and therefore has a shorter radius from center of the wheel to the ground, where the vehicle weight is, compared to all of the other tires. And depending on the information that the wheel speed sensor is transmitting, it will detect a wheel speed sensor that is reading faster than the other wheels. It reads faster because a shorter radius is going to be indicated by a low tire. And as that low tire is rotating, it has to make more revolutions in order to equal a fully inflated tire. So that difference is being monitored by the system. Now the way it monitors is by looking at diagonal averages. The outside wheels of a vehicle during a turn are covering a longer path of ground compared to the inside wheels. As the vehicle is being driven, and it is driven making left turns, right turns, going straight, after enough information has been collected, the system can register what the tire pressure is. And it's programmed to be what is specified on the door placard for the tire pressure. When the vehicle is navigating a turn, the inside wheels on the vehicle are covering a shorter distance compared to the outer wheels on that vehicle as it navigates through that turn. Since this is going to show a discrepancy between wheel speed sensors, in order for the system to not trigger the warning lamp for the driver due to one or two wheels rotating slower or faster than the others, it has to average diagonal opposing corners. In doing this, it can average out enough information to determine whether or not one wheel speed sensor is detecting a low tire more consistently than the others. On these types of systems, since they are not using direct tire pressure sensors in the wheel, they aren't as accurate with providing the driver with specific pressures. I have not seen an indirect system able to produce that detailed of information, but I can't say it won't happen or that it hasn't happened yet. When it comes to checking tire pressure, a lot of people may have this type of pressure gauge. And as this is depressed onto the valve stem, the pressure pushes out this calibrated piece of metal or plastic, and it has different increments of pressure readings on it. So depending how far out this protrudes, you can get an approximate idea of what the tire pressure is. Also, this one goes up to 100 psi. So from 0 to 100 psi, this isn't very sensitive. You're not going to be able to pick up on a 30 versus 32 psi reading. If you are using a manual pressure gauge, make sure that it's accurate. This is an example of one from Mac Tools, and this has a maximum pressure of 60 psi. So most tires are inflated underneath the 60 psi range, with the exception of like a load E range tire that would be inflated up to possibly 85 psi. Then you would have to use a more accurate pressure gauge for that pressure reading. But most vehicles are going to be between the mid-20s and the low 40s. This would work really well. It's manufactured well, it is accurate, and is a good option to use for a manual pressure gauge. Another example is a combination of a gauge with a tire filler valve, with an air chuck valve. So this tool mounts to compressed air, and it has a mechanical gauge on it. This one actually used to have a digital gauge, which I prefer since it's more accurate and there's less discrepancy when reading a digital reading on a screen. But it was plastic and it fell and it broke off, and I didn't want to replace the whole tool. So I was able to replace just the gauge itself with a nice quality gauge, and it's mechanical now. So it is accurate enough that I can trust it. The first step in any of these systems, some information has to be gathered first. We have to check the tire pressure at each wheel. We have to check the sensors if it's a direct sensor. We have to check that sensor with a scan tool designed for communicating with direct sensors inside wheel and tire assemblies. Using a TPMS service tool, there are aftermarket versions available, much like the Snap-on tool. There may be tools based off of the company that builds the sensors or makes the sensors, so Smart Sensor or Ready Sensor. There are a handful of different aftermarket options available. Manufacturers may also have their own type of tool used for communicating with that system, or they may use a factory scan tool with an adapter or some other procedure in order to communicate with that sensor. For the example today on the 2014 CR-V, it has direct tire pressure sensors in the wheels, but it doesn't communicate with the tool directly. It has a manufacturer recommended procedure in order to service it from the vehicle itself, without the use of a scan tool. According to service information, the first step, set the tire pressure to the manufacturer's specification on the door placard. It's important that the vehicle hasn't been driven so you can get an accurate cold temperature. And most tires will increase 1 psi for every 10 degrees in temperature increase. Then step 2, press and hold the TPMS reset button, which is located to the left of the steering column on the dash, until the TPMS indicator lamp blinks twice. Once the light blinks twice, it is now in calibration mode. Then step 3 says, drive the vehicle for 30 minutes between the speeds of 30 miles an hour and 60 miles per hour. Once the system has calibrated, then the light will turn off, and it will only turn back on when there is a fault or an issue with the system. There are areas during the service procedure when dismounting and mounting tires on wheels with direct pressure sensors to pay attention to when we are servicing the wheel and tire assembly. That information will be covered more in detail when we're in lab working on wheel and tire assemblies and servicing vehicles with TPMS. So what pressure do I need to make sure the tires are set to? Cold tire pressure on the door placard says 30 psi for the front, 30 psi for the rear. And we're gonna look for 30 psi. Looks like we're right on 30. We can check the other wheels. Always remember the valve stem caps. And keep all that nice and pretty inside there, free of dirt and contaminants. 30 psi. So we're good to do the rest of the reset procedure on this vehicle since the tires are confirmed within spec. The tire pressure monitoring system is going to perform its own bulb check when the key is turned to the on position. That should time out and turn back off if there are no problems detected in the system. Tire pressure monitoring light is going to be up in this corner, and it looks like a cross section of a tire with an exclamation mark in the middle. It's right there. Just turned off. So when we turn it on, tire pressure warning light comes on, and then it turns off. The next step in performing the reset procedure is to put the system into calibration mode. That's done with this button here. Located left of the steering column at the lower portion of the dash, we have these three buttons here. This one's a blank, this one is for traction control off, and for the TPMS reset calibration. Notice the symbol. Looks like a cross section of a tire with an exclamation mark, just like the warning lamp. Service information says to depress this until the light flashes twice. Now it's in calibration mode and the vehicle can be driven for 30 minutes between 30 miles an hour and 60 miles an hour, and the system should calibrate itself and function correctly if there are no other issues. As always, I hope this video was informative and helped your better understanding of the system for TPMS. Thank you.